are kind of silly because obviously everybody is here. So, so yeah, it's prior knowledge. Java, yay. Running code using a main in IntelliJ, done that a few times. And ability to check out code by revision ID from Git. It sucked the last time we did that. It's going to be a little smoother this time around. We were downstairs the last time we did that. So, hey, it's not the first time. Some things that are helpful but not necessary. If you've started, those can be one annotated method. So if you'll know what they are if you've seen the ones for JDBC. If you haven't seen annotations yet, just know that you have to put at test above the method and don't ask why. Good grief.
Why do I not have to ask why?
Because we don't have time. We don't have time. Knowledge of structures for searching and sorting. As we're talking about hashes, may mention a thing or two about how having an evenly balanced search index is a good idea. If you were interested in how searching works and how sorting works and some of those data structures and have looked at that before, you might get a little something extra out of this. If you have questions and want to talk theory afterwards, we can do that too. But that's a topic we'll... Good grief, stop it.
We lost the screen share.
Is it back?
No.
So it's every time yeah.
I can follow along with you with the slides too, I think.
Oh, yeah. I'm gonna switch over to code though.
Okay.
Yeah. You know, it's got this really sensitive mouse. I have to remember not to. Other things that will help, knowledge of movies from the 70s, 80s, and modern day webcomics. So it won't help you understand together, but you might get a few more laughs. Okay, so for Code Along, you've got 2 links. So these links will have the starter code and the finished code from the end of what we're doing today. So this is what we're going to start with, and this is what it'll look like when we're done. And so I'm going to do these 2 commands here. I can't copy though, so I'm going to come over here. This first one says get fetch. So in your IntelliJ window, you want to be in the one for bookshelf. So open if you have one IntelliJ window open and it's for your project, this won't work. So open IntelliJ in a separate window for bookshelf. If you don't have it downloaded, then hang out with a neighbor. So first thing will be get fetch. This is telling Git, hey, all those commit IDs that you know about out there on GitHub, make sure local version knows about all of them. So it's kind of a refresh button. So then I'm gonna copy this one. Yeah, and so you get a big long thing. It kind of looks like an error. It's actually not an error. But what you do have is head is now at 7AB, JUnit and hashing demo start. And some of this too, if it's taken a while to get the git fetch to work in, that's okay. This will all be on the recording as well to have a much easier time to follow along, because then it's a lot easier to pause the video than it is to pause me. So. But when you see this, head is now at JUnit and hashing demo, you know it worked. So this is not an error, even though it kind of looks like it is.
Who wants to go ahead and do it now?
Yeah, so go ahead and check it out. So it might be a little easier too to see the code on your screen where it's a little bigger than up here on the TV too. Yeah. Okay. So, what if you knew the change that you were about to make your code wouldn't break anything? Or, more likely, you had something that would tell you if you did. So you're trying to code something and you're not really sure if it's going to do what you want. There's all that other stuff that you worked really hard on before. Is it going to break that? Unit tests are kind of like that friend, that roommate that won't let you leave the house if your outfit doesn't look like it matches. They'll be like, wait a minute. So the thing you're about to do, I see what you're trying to do there, but no. Here's the rules. You told me what the rules were before, and you just broke them. So that's kind of what's going on with unit tests. You write some rules that will check your code, and then if you make a change that breaks any of your previous rules, it'll tell you. So a couple things more about manual testing, automated testing. When you don't have any automated tests, you have to remember in your head everything your program is supposed to do. That's why some of those manual testing cycles can take like 2 weeks. Now I complain when it takes 3 hours, but it used to take 2 weeks. You got to get through a lot of cases. Every time you change something, you have to repeat them. So you know that you tested these cases this morning, and then you did some work, and now you're testing them again, and you're trying to remember which ones you're in this morning, which ones you're in this afternoon, what changed in the middle, did it matter, and you're trying to like target just the area that changed, but it's spaghetti code, so things break that you didn't expect to break, and it's, yeah? The truth? So it can be kind of a mess. And you have to click or type them all out. No typos, no mistakes, no distractions. If your dog is running around and then you're trying to remember where you were and you accidentally skipped a test case. And you're not likely to spend precious minutes or precious hours testing every time you make the slightest change. So maybe you'll do that big manual testing cycle for the big stuff. But if all you changed is one line of code, you're not going to go do an hour of testing for every line of code. That kind of momentum would suck. What you actually want to do is get a quick feedback cycle where you can code something, try it, did it work? No, code something, try something. And then you actually learn that cause and effect, because you don't have this break in the middle to have it take a while to answer the question of did it work? So the left side's the manual tests. So automated tests on the right side, because that's super clear from this slide. The right side's for automated. Once they're written, they're saved in your code and you can run them again later. You don't actually have to remember what they were because you already wrote them down and you have runnable code that can check it. One click can run all your tests. So you can just kind of space out, get a coffee, go chase the dog, do what you want to do, let your tests run. Or have a dance party. So JUnit can do some of your work for you. You have to do some upfront stuff to code it so that it's in place, and you have to write good tests, but once you do, you can have a little robot do some of your work for you. And sometimes, not always, but sometimes automated tests run quickly. So while your tests are running, they're running over here, and you can just kind of brainstorm and daydream a little bit about what change you want to make next. So your tests are running, you don't really have to focus on them until they break. Now, there's some things that are just really hard to test. Interacting with the UI is really hard. We're not going to cover that. Full connections where you're trying to go to the database and back, they can be done, but they're sometimes slow. So automated tests can't do everything. It's usually a sweet spot somewhere in the middle of manual testing some changes and then automating what you can. But the more you can automate, the more work, mental load you can just offload to your tests, and then you don't have to think about it, because let's be honest, you have enough to think about. Okay, so let's, oh, that's a duplicate slide. Cool. Okay, we're gonna go over to code for a minute, and I'm gonna introduce you to some tests that we have. You can see what it looks like when IntelliJ runs tests. So normally, so we're used to seeing this little green arrow here whenever we have a main. We can get that same little green arrow without a main. That's not where we're supposed to be. That's where we're supposed to be. So if you put @test, we can do this the right way. @test and import class org JUnit test, this gold @test here. So that will turn any function into a runnable. So you can use this just like you would the main. You are allowed to use that anywhere under this green folder. If your file is not under the green folder, then that will not work. Because test is something you do to check your code. It is not involved in the final build of your product. So if I was to come over to main, or just something here, come over to here. It's not, there's not going to be anything to import, and if I tried to import, where'd you go? If I tried to import, it's going to be red. So tests are only allowed under the green folder, source test Java. So this one is blue, source main Java is blue, unit tests are not allowed there. This is a rule that's designed to separate code that runs from code that tests the code that runs. So they have two separate purposes. So no tests under the blue folder. We'll go ahead and say that also it must be in a file called .java. So this is only for Java files. So we can add this annotation, test. And now we have our green circle to make things runnable. Cool. And the other things that I've imported are org.junit assert, assert equals, and assert true. And so these are going to be, well, it's easier just to show what these can do. So this is a little bit different than your normal main run. So what happened here? So it popped up, so it says it's running. So it popped up a window in your run. But we got all these extra buttons. We've got rerun tests. We've got rerun failed tests. We can filter tests that succeeded and passed. So there's a lot of buttons that we don't have on a normal run menu. And so that's IntelliJ and JUnit understanding each other, knowing, oh, these are some tests. So I'm going to use this extra UI to show these. But we can see that it failed. So it said, actually I'm going to do that one last because so this says, so we can run assert equals. And it said that I expected 1, 2, 3, and I got 4, 5, 6. And so it will tell you that there was a difference. In this case, the expectation is correct, and the actual value should be 1, 2, 3. And now the test passes. So we got our green check mark to say life is good. Everything that the test expected was true. So we can compare numbers, we can compare strings. And in this case, it was also the actual that was wrong. And we're green again, and then we have this last one, so we can also compare Boolean. So there's no expected actual. We just said assert true. There's also assert false. And so you wanted to assert the truth, which is that Garfield is cool, which is obviously true. And so this shouldn't say false. In this case, our data was not correct. And now we have a passing test. So I'm going to write a second one. And you can call these anything you want. It's usually good convention to have them start with the word test. And they do have to be They do have to be public. I'm not sure what's going on there, but certain test runners won't be able to find them. They do need to be public. So I can also say assert less than assert less.
I don't know if I've ever used that before.
Huh?
I don't know if I've ever used that before.
You know what? I think there is an extension that I'm used to using, so I just assumed it was part of the base library. This is easier to read anyway. The ones I've used, I think it was ham crust matchers, which are always backwards.
Right.
Seem pretty backwards. So if I was going to say that 15 is less than 2, that is definitely false. And I'm going to run the entire class. And this button here will let me hide or show the tests that have passed. So now I can see this one's still good, and then this one has a problem. So it can help me zero in on where this is. So if you might have like 20 tests or something happening in this one file, and only 2 of them are failed, you can kind of zero in on just those. So let's change this to 20. And I can say rerun failed tests, because I don't need to spend time running the ones that passed again, because I only changed this one line. And now everything's green. So this sort of covers the how to run it and the how to write assertions, but not really the how it relates to a project or what kinds of things you might need to test. And also these examples are a little boring. So we're going to add a second topic to tonight, and then we're going to come back and unit test our change. So any questions about assert or annotations or where the files go?
Well,
Yeah.
okay, so in relation to the bookshelf, the project. that
Yeah.
you did, I was looking on here and there's like bookmarks control test. So I just want to get more of a real, because I get that, okay, 1, 2, 3, but in terms of like our project, like we said, how do we determine what we want to test? And I mean, you can't give it to us with our individual projects, but in terms of this project right here, if you were going to test, what exactly? Because I want to be able to translate what you just showed me into real thing.
So the question is, what kinds of things are good to test? Anything that's straight Java is usually pretty painless to test. It is testing controllers is a little complicated. We do need an example of how to do that with mocks. Let's see if these work. Let's see. Yeah, these used to work.
Or any of them. I mean, it doesn't have to be the controller, but you said it. You can,
Let's talk about that at the end. Yeah. So bookmarks is now set up to require things to be running against a database. And that's why these are now commented out. So in the JDBC branch, there's an example of how to mock out the database. to test bookmarks row mapper, to test bookmarks DAO. And so that provides some examples on, you wouldn't actually use a live database to test. You can write the test in such a way that you don't have to. And so those are good. That will let you test your DAO. Controllers are kind of tricky because there's a setup for models, and request parameters are hard. Getting the models set up is kind of tricky. I would say the parts of your code that make decisions, that are custom to your project itself. So not the database. So the database interactions. There's a special workshop on how to do that. Not the controllers, but the parts where you make decisions. Like Kelsey's, for example, when she has a list of events where milk has been stocked, and she needs to do a sum over all of them, and maybe 3 of them are rotten, so they're going to be filled out. So there's an if statement in there or something. So just the business logic of the calculations that her project makes, that would be something that's good to test. Another example.
So like things not to test are like things like getters and setters. Like you don't necessarily have to test those unless there's some logic in there too.
Yeah.
Like another way to think about it is like a method kind of has like a contract almost with other code that uses it. So you want to test around the contract. Like if you have a class that's like a calculator class and it has an add and like a subtract and a divide, you would write test cases that would make sure that those that add, subtract, divide all work in how you would figure that they would work.
When you did leap year, that one didn't use JUnit, but it did use a brand of testing where you had an expectation, this or this isn't a leap year, and then it would run the calculation, and then it would give you an output if it was the correct answer. So that one didn't use JUnit, but that one was doing a variety of expected actual comparison. And leap year was actually designed that way, if you remember it, because it's really confusing. And when you have 10 test cases that all operate on the same function, and you don't have to type them in one at a time, you can just press go and it'll test all of them at once. Then you know if your goal of fixing one test case broke the others. So you have a lot of if statements going on. Calculations that you want to get correct. Those are good things to unit test. Or sometimes it can be a good idea to test things that when you're not exactly sure how they worked. Let's say you want to write a function to produce a result, and you're not really sure if it worked. And so hashes are one of those examples of when you want to see the output of a function, and then you can write a test to make sure it stays put. So switching gears for a minute. So hashing functions take a value and they turn it in. They give it an entry and a corresponding table as a placeholder value. And the phrase practical size here is important. So in this example, which is from Wikipedia, actually, we have any possible number of names. There's at least 20 in this room, and all of those have to be mapped to one of 16 values. And so there's some mystery algorithm in between that will map functions on the left to ones on the right. And so what this would, and so 4 things in a good mapping system. That the name Lisa Smith always produces 0, 1, no matter how many times you run that function, so it must be consistent. Collision resistant, which this one is not. So if you have 2 names going to the same hash, that can cause problems. Depending on how you use the hash, you might be able to guard against it. Well distributed. So we have a 1, a 2, a 4, and then a bunch of them that are unused. And so this is the part I was saying, if you want to talk about theory later for hash trees and searching and indexing, having an evenly balanced hash means better performance. Having an unbalanced one might mean that all of your search, if you're searching for something that starts with the letter C, it always takes longer than if you're searching for something that starts with the letter J. So if most of your, you get this really unpredictable search performance where if most of your keys, your range of keys, if most of them would map to the first half of your hash range, those are always going to take longer than, and like this is your search storage over here. So these ones on the second half, there's not as many records in there. So let's say there was something that mapped to an 8, and it was the only one, the only name that mapped to something in that half of the range. That searching is going to be a lot faster. So that's great if you're searching for something that encodes to the back half, but what you'd rather have is a consistent system. And one way. So these are not reversible. This is usually for security reasons. Tony brought up that there is something called a rainbow table attack, where you would actually, if I get this right, you would actually go generate all the possible words you think might be used and all the possible names, and then build a big lookup table in advance. So when you get your hands on the hashes, you just have this lookup table.
Yep. Yeah, most passwords are saved in like a hash form. So if you get like the hash of the passwords, and you have this table over here that's like a like the correlation between a plain text password and what its hash is. Like you could just go through like the table and then pick up the plain text version of it. So that's one reason why you don't use like common passwords, because there are giant tables that you can use for that kind of thing.
So there's lots of rainbow tables that already have test 1, 2, 3 in them.
Yeah.
So if they got their hands on the hashed passwords, they would look to see if test 1 through 3 encoded to that value. So have strong passwords. So what is all this for? Storing sensitive data without revealing its identity. This is a big one, and this is the exercise that we'll do today. So here are some passwords, and this is their equivalent in SHA-256. It's a really, really common hashing algorithm. So you can't tell what the original password was. So even if somebody was to come upon these hashes, they're not going to work if you tried to type them in as passwords. So if I had Jezebel's email address and then all I had was her hashed password, that will not work for a login. So you can't actually use these on a login screen. And note that they're all the same size. So that's, and we're kind of evenly distributed here. So if we were going to go and sort these, Google Slides, please get out of the way. Thank you. So 73050. So out of 16 initial values, we're still kind of in the front half. So this wasn't very well balanced. So you're going to store. You're trying to sort these. Something has these sorted. They're all going to be in the first big shard. So let's say we made 2 big shards of this. Everything's in the first one. So if we're trying to divide our password database into 2, and everything's in the first one, we haven't really divided it. We still have everything to search, one big long list, and then a really short one. That's really just because this isn't filled out completely, but other ones will map to the 9s, the A's, the D's, the back half of this range. So then you can have more evenly balanced search. But we're not really here to talk about search. It can be done, and so that is important. Hashes can also be used to identify very large chunks in a very small setting. And that's supposed to be a link. So if we look at the commits on Git, So these are shortened versions. Let's go to the big one. We have, zoom in? Nope, not really. Yes, we can. So that is a SHA-256 as well. So this is the ID for this whole commit. And it's one of the cool things about Git. All the changes that went into this section, everything that has a plus, if we have other commits, everything that has a minus, so plus this, minus that, all of that text gets fed into a hash generator to produce this ID here. So if you were to go in and have another change that was just a little bit different, it would have a different hash. So it's actually the diff text itself that generates these. So every unique change that you make to your file will have a unique commit ID. And that's where that collision thing is so important. So that would be really bad in Git if you actually had in the same project the same commit hash twice. That would be a problem, especially for things like this, when you're counting on that commit ID to be unique. So Git is able to use a recent change in code to produce an identifier that is always the same length. And no matter how many characters, hundreds of thousands of characters your commit is, you're always going to have the same length. So that's another practical use for them. So we talked about bounce, we talked about that. So storing sensitive data without revealing its identity. So that's going to be our second coding example today. Any questions on hashing theory before we switch over to our code? Anyone thinking, oh, that's what those IDs mean? So let's generate, we've got the, how do we get in code from these strings to these encoded values? So this is our left, these are our left, this is our right from this slide here. So we're going to start with English words, and we're going to end up at some hashes. So our second we have, this is under demos, SHA-256. And this link here is where I shamelessly copied this code. There are, SHA-256 is a pretty popular hashing algorithm. This rainbow table that I was looking at that Tony sent me, it was actually the first one selected on the list. It's the one, Git used to use SHA-1, I'm pretty sure it's on SHA-2 now. There are 3 or 4, I think, really good implementations in Java where people have published code to get from your English words to your hash. There is actually one that's built into the Java language, but it's not the easiest not so easy on the eyes. So instead of using that one, I'm gonna add a dependency to the POM, it's Google's Guava. So I like this one, using this one better than the one that's built into the language because it's a little easier to read and it's a little simpler. If you wanted to see the alternatives, so here's the example in Guava to do the same thing in just the base language. It's a little bit more code. So I'm always a big fan of keeping it pretty simple. So we're going to go with Guava. So I copied this in, and so now I've got this function called to256 that accepts a string and returns the encoded version. This is not a test, this is a main. I'm going to run it with these 5 versions, with these 5 inputs. And so I got 5 hashes coming out. I can also take a really long string much longer text, hash is still the same size. So we know we have a little bit of predictability to how long this ID is going to be. For example, if you have a lot of text, or you have a long password, and you're trying to figure out how long your column needs to be in your database, you know it never needs to be longer than the length of the hash. So got a predictable length. And then now that these are all kind of the same size, it's a lot easier to do other sorting things with them that we'll talk about another time. So we can use this method to generate and hash these values. So I promised that there would be functions and if statements and things that would make sense. So now I'm going to give our brains a break for a few minutes and we can talk about things that are a little more familiar. So this is a password checker. This is our good old-fashioned scanner, where you have 3 attempts to guess the right password. The password is exclamation point 2, 3, 4, 5. Very secure system. Right there in the source code, this is actually checked into Git. This is bad. Don't check passwords into Git. Even if it means that what you've checked in doesn't work, don't do it. Not a good idea. We did it. It's got a commit ID. The commit ID is right here. Come on, gonna go up. So we can go right here to this link. Password, much secret, don't tell. So don't do that. Yeah, we're done here, I think. Yeah. All right, here's intelligent. Okay. So we're gonna fix this using a hash to make this a little more secure. But first, a review of some Java. So you'll have 3 attempts to guess the right password using the isPasswordCorrect function, which compares our secret password to the one that they've entered. And then if they guess it right, they are rewarded. If they guess it wrong, they are mocked. So I'm going to try to guess 1, 2, 3. 1, 2, 3, 4. Password. Nope. Let's try it again. 1, 2, 3, 4, 5. Nope. 2, 3. Yes. So we have guessed correctly. So we've got a working password checker, but it's not really super secure. So back in these slides, I mentioned that in this system, Lisa Smith will always go to 01, no matter what, in a good deterministic system. Also, good passwords are hard, but coding is harder. Will always map to this first value here. And code will always map to this one. So if code's always going to translate to this one, that means that if my password is code, and I send it through this hashing algorithm, I should get this every time. So I can compare these in plain text, or I can compare the hash of them. What? So let's try this instead. SHA-256. So I haven't really changed a whole lot here. So before I was comparing 1, 2, 3, 4, 5 to 1, 2, 3, 4, 5. Now this is comparing the hash of that to the hash of the same thing. So it's still we haven't really changed anything yet because the password is still in plain text. But I like to take small steps and make sure it's still working. Okay, so it's still working. I made a small change. I haven't broken anything yet. This was a manual test. Would have been a little better if I could have just run some unit tests. I didn't have to type stuff in, but it didn't take too long, so that's okay. Also, keyboard inputs are really hard to test. If you have something else you'd rather test that you can test, do that first. Testing keyboard inputs can be kind of a pain. So I'm going to generate the SHA, the hash for this not so secret password. Let's run this. Okay, so 9EED0. Let's run again. 9EED0. Alright, every time. It's the same thing every time. So now I know that the 256 of our password, 12345, is always going to give us this 9EED0. So, instead of the hashed version of our password, we have the hashed version of our password. So once again, instead of the hash of our password, we replace that with that value. So now I'm going to go back here. Let's just run this first before. And let's see if it works. That's not running now, so 3, 4, 5, not a match. 1, 2, 3, 4, 5. That's a match. So we'll bring this back. Nope. So the password exclamation point 2345, it's not in the source code anymore. However, when I ran it, it still knew that it was the right one because we took what I entered, calculated the hash for it, compared to the known hash of the password. So now I have the exact same behavior with the exact same password, but you can't find the sensitive data anywhere in the source code. So now, maybe this is your user's password. You can take this password, you can save it in the database, and if somebody does come along a column with the passwords in it, they can't do anything with it. But you can still double check someone's login using that value. So without ever actually storing your user's passwords, you can still check that they're entering the right one. There's also a great site called plaintextoffenders.com, where they email you your password in plain text. This happened to me once. It was from a tech conference that emailed me my own password, and I was horrified, and I immediately shamed them on this website. Yeah. So don't end up on plaintextoffenders.com. Hash your users' passwords before they get saved. It's a good habit to get into. There's another one, not in English, it would be in Swedish. Somebody sent someone their password in Swedish. And We got another one, and so there's a whole feed. It's just a whole wall of shame of different websites out there that people figured out that they were storing the passwords in plain text. You want a good system. You want a good system. You want a good database. You want something that's intrusion proof. But if an intrusion happens, passwords are real sensitive. So by having them hashed, even if there was a break-in, they can't do anything with this. So this is one of the ways that you can keep from your work ending up on plaintextdefenders.com. So I promised that we were going to do a unit test with something a little more interesting than numbers in Garfield. And for that, we're going to start with, we're going to make a brand new unit test from scratch. So to make a test, again, look for your green folder. Make sure you're under your green folder. And I want to test a user class. It's a real boring test that's just a pojo. And usually there's nothing interesting to test here, but I'm going to put something interesting here. So this is under Codergirl Java Bookshelf Demos. Under the green folder, we have Codergirl Java Bookshelf Demos. Okay, so it goes here. Our packages match. So we see org Codergirl Java Bookshelf dot bookshelf. There's two. Oops. I'll fix it later. So we're going to make a first test. That test. That happened really fast, but IntelliJ went and imported the meaning of that aspect for us. And public void test user is secure. So I'm going to make a user. And let's see, in the constructor we have username, password, quest, and favorite color. Username, Jane Coder. Password, Japanese cool. Quest. Nope, this is not Python. To learn all the things. And favorite color, still not Java, is Jade. This is Java tonight. And so before, we had these asserts. Assert equals, assert true. So I can check those again. I'm just going to do some of them. Assert true. Import to static method. Org JUnit. And user dot, you know what? Let's make this a little, call this Jane. Assert equals. Oh. Okay. So I have no way to get the username out. But I wanted to. I wanted to have this. Well, I've kind of already written what I want it to do. This is how I want to call the method. I'm going to click on this little balloon right here and say create read-only property. Okay, well it didn't match it exactly, and now I got two usernames. That's not what I wanted. So it didn't really capitalize it correctly. Okay, so that'll return get username. So I can make sure, so now I'm testing, really I'm just testing the constructor and this getter. So I'm testing those two things. And test passes. So I'm going to do one more. Equals yeah, and we got to do all of these getters. So come over here and change this one to get password. Cool. Obviously this is a really easy Pojo, nothing could go wrong. So this test caught my mistake. I expected Java is cool, or password. I got a username. So our test caught this mistake. We caught this mistake before we started Spring Boot, before we started running, before we started entering data. This really simple thing, which ended up looking like white label error 500 sucks to be you, which is what you normally see when something goes wrong. Instead, what you could actually see is that you have something right here that just caught a really simple problem. So let's change this to password. So now my confidence in this class is increasing, that it's doing what I think it's doing. I thought it was doing that before, but then my test got me on it. So that's using this to test something simple. But now we have something you might encounter when you're building your page, which is that I've got these plain text passwords in there. They might be writing out to the logs, they might be writing to the database. We need to do this hashing thing that we just learned about so that we're not storing anything in plain text. So let's take Java is cool, come over here to our handy, we don't want 1, 2, 3, 4, 5 anywhere in our code anymore, so let's do it right here. So I'm going to run this little checker. So it says it's Java is cool becomes something that ends in 66A6. Yep, starts with E. A few more times. Okay, I'm convinced it's the same thing. I didn't really need to run it more than once. It's just kind of making the point that a little easier to read. So we got this big old value here, and that's what we actually want to come out. So is this going to work? Why not? Yeah. So I expected this one. So I wrote this test to describe what the user class should be doing, but I didn't actually change it. I didn't actually update the user class to add this security change. So I could add this in two places. I could do it in get password. But actually I'm going to go ahead and just do it right here. Now, as soon as, so this password is going to get sent to that controller, and then as soon as it gets sent, before any of your controller code actually runs, it's just when your model is doing its bindings, it's going to run this hash, and you will never see that plain text password again. It's gone. So now, Java is cool was our password, and it's going to be stored like this. And every time I run this test, it passes. So every time, that's a very reliable, very deterministic SHA, or SHA-256 is a very reliable hashing algorithm. It's always going to give me the same value for Java is cool. And there's one last thing I'm going to do, just so I don't confuse myself later. is I'm going to rename some of these method. So this is going to be password hash. This one is going to be password plain text. This one is going to be password hash. So now I know which one is which. Because I had two different strings and they were both called password. And it's a little harder to keep track of which one's which. So I just retired the name password entirely. Password hash, password plain text. Just like a good tip for not confusing yourself with code that you wrote a couple weeks ago. So if I was to give two different things the same name, that's kind of rude. So now I'll give two different things, have two different names. I just retired the original name password, so it's gone. So this test is a little more interesting. At least something was happening here. And we were able to use this unit test to catch the fact that I had some copy pasta here. And then we did a little bit of test-driven development, actually, where I wrote a test describing what I wanted this class to do, wrote an expectation, saw it turn red that the class wasn't meeting the expectation, and then updated the user class to match it. And when you do it that way, it's a style called red-green testing, sometimes called red-green refactor, where when you kind of know what change you want to make and you do the test first, your test is always a living description of what your code does. And in fact, it's a little bit easier to read because we don't even see 256 SHA anywhere in here. What we see is I started with this password and got this one. So the test describes what the user constructor does without describing how it did it. And this can be really helpful when you're planning your code because a lot of times you don't know how you're going to do what you're about to do. You know what you want it to do. You don't know how you're going to pull it off yet. So when you're writing your tests, you can say, I want to start with plain text and end up with something more secure. And see your test fail and then figure out how to get there. And because you started with a failing test and got it to pass, you can trust that green dot, that those expectations you set before are now working. So, to Stacy's question earlier, so this is a good example of something you'd want to test. One, it's pure Java, so it's nothing external, no external databases. There's nothing mysterious going on as far as bindings and going from HTML is not involved. Spring MVC can be tested, but it's a little hard to test. So this is plain old Java, and this is something that when you first wrote the test, maybe you didn't know how you were going to finish it off. So that's a good thing to test, especially when you're first starting out. Get in the practice of some asserts, some red-green, and the refactor is about cleaning up the code. So that's where I went ahead and changed the name. So I'm not going to go into mocks today because if you say your brain isn't full, you're lying. On the branch, so wait, how did I get here? On the branch, 2 branches, active branches, JDBC demo, starter code? Yeah. So, in the starter code for the JDBC demo, you saw a couple weeks ago, it's also this one. Okay. Okay, but definitely been talking too long because Bookshelf was running when we started this, and now it's gone to sleep and has to be restarted again. So.
I've got that pulled up, but
Yeah.
the 256 demo is yelling about having to import Google and the hashing.
Okay, hang on, I'll come check it out in a second. So, create your first DAO class? Yeah, so the code that we're talking about, the code that we're talking about in this one, this create your first DAO class, that one also has a unit test in it. Here's our @test, here's our asserts. I was calling bookmarks row mapper. This is the thing that I was calling. The setup for this one was a little weird though, because I wanted to test, in this case, bookmark row mapper, that class, without having H2 running. And so I had to do this thing with mock. That's Mockito mock, where instead of using an H2 database, which is not running when this test runs, I mocked around it and then gave it this kind of funny expression that says, when I called the getInt function, do this, do this, do that. So we can talk about mocks when you're ready. Just kind of come up to us one-on-one, and we can do some pairing on how to set that up. You can have tests if you want to just start Spring Boot, and then H2 will be running. You can have tests that just go out and hit, like test your DAO that just go out and hit the database. They will fail if Spring Boot is not running, but then you don't have to deal with mocks. So if you want some tests that work when your application's running, just to run them a few times, you can do that. Otherwise, when you're testing your DAOs, if you'd rather them be working all the time, you can sit down with us and we'll walk through how to do mocks. They're really not that bad once you do the first few, but I think we've probably covered more than enough for one night. So let's check out some questions. I'm going to keep this rolling here because I think this might question me. When you're running these for the first time, there's one thing you want to make sure you do. So when you check this code out from the beginning, this will be grayed out. I did that so that I would remember to come over here and talk about it. So if I went to run this unit test intro, hang on. I get a compile error. Cannot find symbol called hashing location here. Hashing is not found. Google. Oh yeah, Google doesn't know what this class is. So come over here to your POM file, add that in, and import changes. Okay, so now if I go back it was red and now it's green, so now it knows where to find it. Hashing here is now in our Maven repository, so in that quick minute there, Maven went out and downloaded that jar for us, published code from Google, so that we have it. So do make sure to include your dependency from the pond file. Yeah, good question, good catch. Glad that got into our recording. Any other questions? Hashes, tests?
A lot of information tonight.
A lot to digest.
Yeah.
I'm gonna have to watch that again.
Yeah.
So I have no intelligent questions right now.
Cool.
For me personally, but
Well, if YouTube is on our side, then this will be recorded. So, and that's part of the intent of recording it too. So those can be paused. You can practice, kind of do things at your own pace. All right.